the Pacific Northwest, both the land and the climate are ideal for growing trees. Here, wide areas of privately owned land are managed as tree farms. Here, forests of huge old trees stand side by side with infant crops of healthy firs and hemlocks, growing with the help and protection of experienced industrial foresters. Part of the land is in youthful crops of clean trunk trees. On other land, crops are coming rapidly to maturity. All are protected from fire by men and equipment operating over the tree farm's network of roads. Whatever their size and species may be, all the trees are storing up a promise of houses, clothing, books, and paper for people everywhere. A promise built by the tree's remarkable processes of growth. Just beneath the bark, every tree is completely covered by a fragile layer of living material known as the cambium. The cambium produces all the wood in a tree, leaving a permanent record of each year's growth in alternate bands of color. A microscope focused on the area outlined in white would reveal tiny individual fibers of wood and bark and the living cells of the cambium layer. In the jelly-like cambium layer, a single row of cells contains the tree's power to grow and manufacture wood, for these cells are able to divide in two. A new cell has just been made in the cambium layer. Over a period of weeks, it will change itself to a fiber in newly formed wood. First, the cell expands by pulling sap, shown here in blue, to a cavity inside. Now the cell begins to build walls of a strong, flexible substance known as cellulose. Lignin, shown here in brown, is a tough, hard plastic. It fills the spaces between the cells, cementing them rigidly together while the walls continue to grow. Thus, each new cell becomes a tiny fiber, less than half as thick as a human hair, and is locked in newly formed wood. New wood forms minute by minute, day by day, under every square inch of bark on every living tree. The countless hollow fibers so formed lend lightness and strength to wood as a building material. The complex structure of cemented fibers is cross-bound with other fibers called medullary rays. A wood fiber is about 90 times as long as it is thick. Separated from wood, the fiber is tough and flexible, ideal for making paper. Its cellulose walls are raw material for such important products as rayon and cellophane. On tree farms, fibers and wood are the crop, and tree farmers are in the business of growing wood at the greatest possible rate. Tree farmers know that different trees grow at different rates. In crowded stands, darkness holds back growth and slowly kills the weaker trees. Tree farmers know how to select trees for removal, so the stand will grow rapidly once more, and so excess trees can be taken for use as pulpwood.
Ready, boy. Ready. Ready.
When a stand of timber gets very old, wood is lost faster than new growth can replace it. In such stands, natural forces of destruction are at work. Foresters notice the dying tops, fungus diseases, and trees destroyed by wind. Here, one by one, the trees are being lost. On tree farms, carefully planned harvesting puts the timber to use and clears the ground for a new crop. From cones on nearby trees, millions of seeds drift into the clearings, establishing new crops of tiny seedlings, carrying the promise of the trees far into the future. From this hillside of very old timber, 2 areas have already been harvested. Farther out along the hill, tree farmers have selected another area and are just beginning to harvest the timber. Here, small trees, ideal for pulpwood, have crowded in among big old Douglas firs. The small trees are yarded to roads with light, high-speed equipment in what is called the pre-logging operation. Many of these logs would be broken and lost if not removed before the fallers go to work on the bigger timber. After the big trees are felled, crews using heavier equipment systematically pick out all logs and pieces of practical usefulness and move them to the roads. Tree farmers not only know where to harvest, they know how much to harvest. On every tree farm operated by a Weyerhaeuser Timber Company, the wood removed in a year is carefully balanced with a year's growth on the tree farm as a whole. As the loggers finish each area, a forester trained in wood utilization follows up. He inspects all pieces that look as though they might be useful. He sees many a victim of old age, disease, and rot. He knows that for such logs, the harvest has come too late. Their wood and fibers can never be put to use. But harvested logs are just beginning a journey toward 1,000 uses, for logs are nature's bundles of fibers, bundles moving from tree farms to integrated manufacturing centers, where pulp mills, sawmills, and plywood factories work together to use all the wood from all the different kinds of logs. At integrated plants, each log comes under the eyes of expert sorters who judge the products promised by the wood and send the log to a sawmill, plywood factory, or pulp mill, whichever can use it best. At the very beginning of manufacture, hydraulic barkers remove all the dirt and bark so that every part of the logs will be clean material for either lumber or wood pulp. Logs entering sawmills go to head rigs for the first of many cuts by many kinds of saws that will separate each log into lumber, timbers, and many odd-shaped pieces that are finally used for pulp. In plywood factories, huge lathes turn selected logs into veneer. Thus, wood that was once a promise in the trees becomes plywood and lumber, ready for shipment and use as material for buildings and homes. Slabs, trimmings, and edgings left over from lumber and plywood manufacturing contain countless valuable wood fibers. They are part of the raw material used for pulp. More pulp material comes in from thinning and pre-logging operations. And many big logs are of species most desirable for pulp. All this material goes to chipping machines, which will make them into wood chips of uniform shape and size. Average wood chip contains about 1 million tiny fibers, still tightly cemented together, just as they were in the tree that made them. Silos at pulp mills receive chips and store them in readiness for processing into wood pulp. Pulp mills are permanent installations, operating around the clock, 7 days a week. They require reliable supplies of wood and water, and good transportation facilities. The complex arrangements of buildings and equipment are all necessary to release cellulose fibers from wood and purify them on a mass production basis. Important sections of each mill make chemical solutions used in the pulping process. Some mills make alkaline solutions. Important sections of each mill make chemical solutions used in the pulping process. Some mills make alkaline solutions. And others prepare mild acids. Both kinds of mills use the same principles and similar equipment to make pulp. Each mill houses a battery of enormous pressure vessels known as digesters. Here, wood chips and chemical solutions come together under heat and pressure for a process known as cooking. 60 feet above the ground, the flanged tops of the digesters project through the control room floor. On the floor above, a conveyor brings chips in from the silos and drops them into the digesters. With chips inside, digesters are sealed at the top. Cooking liquor comes in from the bottom. The man in charge of digester operation is the cook. He is responsible for the quality of wood pulp produced from each charge of chips. Now the digester is full of cooking liquor. A pump circulates the liquor through the chips. With instruments, tests, and experience, the cook guides all important changes taking place beyond human sight or reach behind the walls of the digester. Cooking liquor becomes strongly active under heat and pressure. It begins to penetrate the fibers of the chips. Lignin gradually dissolves, loosening its grip on the cellulose fibers. And when cooking is complete, the chips are ready to fall apart into individual fibers. Now pressure will be relieved and the digester emptied into a pit. When liquor is drained off, wood pulp consisting of separated wood fibers remains in the pit. This is sulfite pulp. Kraft pulp is made in a similar way, but in different mills, using different cooking chemicals. After cooking, kraft pulp is dark brown in color. All traces of spent cooking liquor are removed on rotary washers. The pulp is flooded over screens, which let through only completely separated fibers. This unbleached kraft pulp is moving toward the next main section of the mill, the bleaching section. As it moves, samples are tested to find the exact amount of chemical needed when the pulp reaches the bleaching section of the mill. Chemical reactions of bleaching take place concealed from view in tanks and towers. At the top of each tower, an open washer reveals something of the changes being worked by the bleaching chemicals. Elaborate instruments help the head bleacher man keep the 6 gentle treatments of bleaching under strict control. As it enters the last stage, the flow of pulp is divided into small batches for close control of strength, purity, and color. Thus, fibers formed in trees become wood pulp of sparkling cleanliness and purity, moving toward the last major section of the mills. In machine rooms, bleached pulps are prepared for shipment to market by a machine that spreads wet pulp in a continuous sheet. The pulp is drained and pressed, then dried at moderate temperature in a huge vacuum chamber. As dry pulp comes out, quality control technicians are running continuous tests. After refining in miniature pulp beaters, samples are put in standard laboratory molds to make small sheets of paper. A typical test of strength and quality is one for endurance of repeated folding. Meanwhile, records of every step in production of every lot of pulp are filed in record rooms. Information compiled will guide planning of further developments in mill equipment and processes. Every fiber in a bale of pulp was once a unit in nature's production of wood. Now each fiber is destined to be a unit in man's production of completely different substances. The different kinds of pulp are material for papers that will last a century, or for fabrics, films, and plastics of almost unbelievable variety. Huge volumes of this wonderfully useful tree farm product are shipped from the Pacific Northwest to mills and factories in every part of the country. Chemical industries making rayon and cellophane use wood pulp as an abundant source of pure cellulose. In these mills, the cellulose walls of the fibers are completely dissolved to make a thick syrup called viscose. Cellophane is one of the widely used products made from viscose. But more important yet is rayon, made by squeezing viscose through tiny holes into a bath of acid. These filaments, gathered together, make a single strand of rayon yarn, which might be used in rugs, tire cord, or clothing. Cellulose is part of the promise stored up by growing trees. Viscose rayon is practically pure cellulose, transformed to fabrics of outstanding color, beauty, variety, and value. An entirely different use for pulp is found in mills making paper, container board, and carton material. Materials made on machines called cordonniers. Unbleached kraft pulp is made into container board, a rugged, uniform material for corrugated boxes. Bleached pulp goes into the stiff, dense, odorless material used for butter and milk cartons. Paper mills specializing in finest grades of writing, printing, and business papers are most particular about quality and uniformity of pulp they use. Machines called beaters begin refinement of pulp and thoroughly mix it with other ingredients of paper-making stock. Refining is carried forward in machines called Jordans, which put the fibers in condition to form together in a smooth, strong sheet when they reach the cordonnier. Paper is formed on an endless, fine screen belt called the cordonnier wire. This is a cross-section of a cordonnier with the wire at eye level. It shows how refined wood pulp fibers are put together to make paper. Stock flowing onto the wire is about 300 parts water to 1 part of pulp. As the wire moves along, the water drops through. The refined fibers settle on the wire, interlaced together in a newly formed sheet of paper. The sheet is already strong enough to support its own weight as it leaves the wire. Steam-heated rolls drive out all remaining moisture, and perfectly formed paper moves steadily onto the winding reel. Every sheet of fine paper is inspected before shipment, for pride of quality and craftsmanship is traditional in the ancient art of papermaking. For people in every walk of life, the promise of the trees comes true when they use and enjoy the multitude of products made from wood or fibers. To them, quality lumber moving from the yard to a building site carries the ability to shelter a family in the security and comfort of a good home. Fine rayon fabrics appeal instantly to people who appreciate style and quality in the clothes they own and wear. With abundant paper, the printing industry satisfies the demand of modern people for books, magazines, and printed materials endless in their variety and usefulness. Paper is a basic material in schools, a carrier of knowledge to children's minds, helping each one to the measureless benefits of education. Everyone uses paper to communicate by mail, to exchange ideas, news, and information with people in distant corners of the land. Records of all the important events in life are committed to paper's perfect memory of the written word. In thousands of business offices, paper helps regulate the flow of all the things people need and use. And wherever goods are moving, there are products developed from the promise of the trees. Food comes to market in container board shipping cases. It comes to customers' hands in clean, attractive packages that add immeasurably to the convenience of everyday shopping. In hundreds of ways, people everywhere benefit from the power of living trees to grow and form new wood. Such benefits live on in each successive crop of timber. Tree farmers in the Pacific Northwest are working, planning, increasing the yield of tree farm land, making tomorrow's promise of the trees greater than ever.